Hi everyone, welcome back.
This week, we'll be talking about some of the trickier math problems. These are the types of questions you will see towards the end of the math test. These can seem scary, but we'll be breaking these problems down and sharing some strategies to make you feel more confident when you approach them. By getting better acquainted with these problems, you'll also save some time, which is always a good thing.
Some things to keep in mind during this lesson. Problems from year to year in the ACT do tend to be repetitive, so knowing how to solve these representative problems will go a long way. Also, be sure to follow our step-by-step process and work out these problems with us as we go along on a piece of scrap paper.
Alright, let's get to it.
The first challenging ACT math test question from a previous practice exam that we will consider is going to test your knowledge of the quadrants of the unit circle and how to measure angles in each quadrant. We're given a unit circle here with some points and are told that only when angle COA, that is the angle here that's labeled alpha, is measured in the direction of the arrow shown, so that's in this case counterclockwise, which is the direction that we generally measure up angles in the unit circle. Its measure is alpha. Similarly, when angle COB, or this one here, labeled here beta, is measured in the direction of the arrow shown, its measure is beta. Now both alpha and beta are positive. So far so good. Remember that whenever you're presented with a unit circle, you'll have positive values being measured counterclockwise from what is generally labeled 0 here. And as you move on, hopefully you remember, you'll have pi over 6 as your first angle measurement, positive pi over 6, then pi over 4, pi over 3, pi over 2, etc., etc. And as you go along all the way back to 2 pi, or 0, which is where you started, the numbers will get increasingly greater, more and more positive. But now the question is, what is the measure of COD, which would be going in the direction of the arrow, which is clockwise here, the direction of the arrow shown. And it's just something you may not have seen before in school. But we want to make the assumption that if we're going to be going in a counterclockwise direction and getting more and more positive numbers, and now we go in a counterclockwise direction, we should be getting a number that will be negative. If the value of these of the angle subtending arc CD were to be known, whatever value we get for that angle, we should make sure that that angle is negative, not positive, as when we were measuring angles in a counterclockwise direction. Okay, enough of that. What is the angle subtending arc length CD? Well, arc length AB, we're told, measures the exact same as angle CD. The length of arc BA is the same as the length of arc DC. Okay, so if that's the case, then the angle subtending each of these arcs must be the exact same. So let's go ahead and label it X for when it subtends arc length AB. So if it's X for arc length AB, it's going to have to be X for arc length CD. But this X value will have to be negative. Now all of our answer choices are in terms of beta and alpha. So if we figure out what angle X is for positive beta and alpha, we should be able to figure out what it will be when it's negative, when it's subtending angle or arc length CD. So let's go ahead and figure this out. If X is going to be less than alpha by theta, that is if you were to add up, by beta, if you were to add up beta and X, you would get alpha. That means that you can also say X is going to equal alpha minus beta. So if we subtract beta from alpha, we're going to get the measurement of angle X. Well, if that's the case, then our answer choice, which has to be negative, will simply be negative 1 times alpha minus beta. That is, we're going to get beta minus alpha. And that should be answer choice H here. All we did was make the assumption here that when we will measure in a clockwise direction as opposed to a counterclockwise direction, the angle measurement will have to be negative. The reason the answer is not alpha minus beta is because the x value that we assign to the angle subtending angle AB has to be negative when it's subtending an angle measured in the opposite direction. In this case, in the fourth quadrant. So we're going to multiply alpha minus beta times -1, giving us beta minus alpha.
This problem can become pretty tricky pretty quickly if you try to solve it by algebra. But if you use the strategy of picking a number, you can make things a bit simpler for yourself. So since percents are base 100, let's pick 100 as our number to start with. Now, we're going to increase 100 by 10%, like it says in the problem. So in order to increase 100 by 10%, we're going to multiply 100 by 1.10, where this 0.10 is equal to 10%, and this 1 represents the original 100, which we're increasing by this 10%. So when we do that, we end up with, well, just 110%, because it's very straightforward to take a percentage of 100. And now that we have this 110, we want to increase that by 20%. So we're going to do the same thing here, multiply by 1, but since it's out of 20% this time, it's going to be 0.20, and then see what that equals. This is a little bit trickier to calculate, but a good strategy for whenever you're taking 20% of something is to take 10% and then double it, right? So 10% of 110 is going to be 11. We move the decimal place over right here. That's how we get the 10%. And then if we double that, we're going to get our 20%. So here, 1.20 becomes 110 plus 20% of 110, or 0.20 times 110. Now here we're going to get 132. Once you have this number 132, you want to subtract your initial number that you picked, 100, and then place it over 100 in order to find percent increase. So 132 minus 100 equals 32. And if we place that over 100 to transform it into a percentage, we're going to get 32% as our final answer. And if you look over at your answer choices, this is going to be answer choice F.
Another challenging problem from a previous ACT practice test is this one here. They give you a cube with edges 4 centimeters long, so we know that since it's a cube, the length, the width, and the height are all 4 centimeters. And they tell you that it's inscribed in a sphere, as shown in the picture. Only with that information, then, they ask you what the radius of the entire sphere will be in centimeters. Well, we're not going to be looking for the radius of this circle here. So that's the first thing. We're looking for the radius of the sphere. But that shouldn't make much of a difference. At the end of the day, the radius of this circle would be the exact same thing as the radius of the sphere. We are not restricted to look at the measurement of a line from the center of this circle to the edges of the circle drawn, however. One thing we can do that would be very helpful is if we figured out the measurement of the line from one edge of the cube to an opposite edge of the cube with the type of diagonal here that we could draw from these 2 points. I'm going to label the first A and the second B. Figured out the measurement of this line, we would have the length of the diameter of the cube. So I'm going to go ahead and label this D for diameter. And if we divide the diameter by 2, we would then have the measurement of the radius of the cube. Of the sphere. And with that information then, we could go ahead and figure out our answer. Well, if that's what we have to do, then we could imagine that we have a triangle where we're going to have the diagonal of the square base from A to what I'm going to label point C here be its one of the legs, and then another leg will be from point C to point B, labeled here, and the hypotenuse of this triangle will be this diameter of the sphere from A to B. We don't know much about this triangle. It doesn't seem to be a special triangle in any shape or form. All we know is that we're looking for its hypotenuse, and that the length of BC, since it's one of the sides of the cube, is 4. So basically, I'm going to go ahead and draw it one more time. We have a right triangle with one side 4. We want to know the length of its hypotenuse because that's going to be the diameter of our sphere, but we don't know anything else. Well, the diagonal of the square base here is equal to point AC. So if we draw out the square, it's got its diagonal. It is the same as AC. Now you have to remember, every time you take the diagonal of a square, you are looking at two 45, 45, 90 triangles. This 90-degree angle at point A and the one at point C is basically split into two, with two 45s on either side, and then the other 90-degree angles that have not been split to create a diagonal remain 90 degrees. And 45, 45, 90 triangles share something special. The length of the legs is always the same, so they're always isosceles, which makes sense. Here we know that this is a square with side 4, so of course the length of the legs here will also be 4, and its hypotenuse will always be the length of one of the legs times the square root of 2. So that means that the length of the hypotenuse, or the length of AC in this case, is going to be 4 root 2. Okay, well if we know that AC is 4 root 2, we know that CB is 4, and we're just trying to find the length of AB, and this is a right triangle, well, we could use the Pythagorean theorem, which says that the length of one of the sides squared plus the length of another of the sides squared equals the length of the hypotenuse squared. So let's go ahead and take AC squared plus CB squared and say that this is going to equal AB squared. Let's begin with AC squared. So this will be 4 root 2 squared plus 4 CB squared, and this will give us D squared. Well, 4 root 2 squared, if we square each term at a time, it'll be 4 squared, or 16, times root 2 squared, which is just 2, plus 4 squared, 16, and this will give you D squared. So basically we have 32 plus 16 gives you D squared. In other words, we have 48 gives you D squared. Okay, so at this point, we're very, very close to figuring out what D over 2 is, which will give us a radius and the answer to what the radius of the sphere is. So I'm going to go ahead and continue working in this space here next to the answer choice. The square root of 48 then is going to give me the measurement of d. We're going from 48 equals d squared all the way over here. So the square root of 48 equals d. So the square root of 48 is a square root that you might not know from memory, but we can split this up into chunks that we do know. The square root of 3 times the square root of 16, for example, since 3 times 16 gives you 48, would give you d. The square root of 16 we know to be 4, so then we can just simplify that to 4 root 3 equals d. And finally, we have the measurement of our hypotenuse. It's just 4 root 3. But we want not the measurement of the hypotenuse or the diameter of the sphere, we want the radius. So we're going to have to divide it by 2 to get our radius. So r equals 4 root 3 over 2. Or otherwise, 2 root 3, which is answer choice F.
Here we want to use this first function in order to solve this second function. So in this second function, x squared plus y squared, comma x minus y, we can think of x squared plus y squared as our a, and x minus y as our b. So that means, since we know that f of a comma b equals b squared minus a, we can rewrite this as follows. First, let's take our b squared in this second function, which is x minus y. So x minus y squared, and then let's subtract our a, which is x squared plus y squared. And now what we want to do is factor this out. So we're going to get x squared minus 2xy plus y squared. And then when we distribute the negative, we're going to get minus x squared minus y squared. Here, our x squared will cancel out, and also our y squareds will cancel out. In the end, we're left with minus 2xy as our answer for what's f of x squared plus y squared, comma, x minus y equals. That is going to be answer choice K.
A common challenging problem on the ACT math test asks you to use trig identities to solve an equation. Now, don't feel like you need to memorize all the trig identities for this exam if you have not taken trig yet. They will give you tables of values or other ways for you to figure out what the sine and the cosine of whatever number they want you to know at the time is. If they don't give you a table, they will draw out triangles so you can solve it using SOHCAHTOA, but one way or another, you will have the information in front of you. What is different about this one is they give you an identity right here. This is an application of our sum difference identities, where the sine of alpha minus beta equals the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. And they also tell you that the number that we're looking at here, pi over 12, that we're taking the sine of, that input, can also be pi over 3 minus pi over 4. This, of course, is because when you are subtracting fractions, you want to get a common denominator, and by multiplying pi over 3 times 4, you get 4 pi over 12. and multiplying pi over 4 times 3 in both numerator and denominator, we get 3 pi over 12, and 4 pi over 12 minus 3 pi over 12 equals pi over 12. But enough of that. The information is given to you, so even if you didn't realize those things, it's written down. All you have to do is plug in and try to figure out the problem. So let's go ahead and do this together. So the sign of alpha minus beta, where we know that pi over 12 is the same as pi over 3 minus pi over 4, would be simply sine of alpha. In this case, let's say pi over 3 is alpha. Sine of pi over 3 times cosine of pi over 4 minus cosine of pi over 3 times sine of pi over 4. Now that we have it like this, we've plugged in to the equation that they've given us, to this identity. All we have to do is, using this table, figure out what the values of each of these functions is. Well, the sine of pi over 3 is just going to be, we're going to go ahead and look at sine over here, pi over 3, and match, and we get square root of 3 over 2. For the cosine of pi over 4, we can do the exact same thing. Cosine pi over 4, match over here, and we get times square root of 2 over 2. And then for the cosine of pi over 3, cosine pi over 3 matching here, 1/2. And the sine of pi over 4, sine pi over 4, square root of 2 over 2. Now, when you're multiplying fractions, you're just going to multiply the numerators and the denominators together, right? So the square root of 3 times the square root of 2 will give you the square root of 6, and 2 times 2 will give you 4, and then minus, and then here 1 times the square root of 2 is just square root of 2, and 2 times 2 gives you 4. So we get the square root of 6 over 4 minus the square root of 2 over 4, which is just the square root of 6 minus the square root of 2 divided by 4. That is answer choice K.
So here we're trying to solve for this expression. Let's first rewrite that expression and see if this helps us. Using the properties of logarithms, I'm first going to take care of the exponent right here. So we can say that log a of xy squared equals 2 log a of xy. We can also say, now using another property of logarithms, that this equals 2 log a of x plus 2 log a of y. Excuse that ugly y. And now I see that I have x and y. I have x and y also right here. So I'm going to solve for x and y in both cases using another property of logarithms. So log a of x equals s can be written as s x equals a to the s. And in the same way, we can rewrite log a of y as y equals a to the t. Now, we're going to plug in for x and y down here. 2 log a of a to the t plus 2 log a of a to the t, and this should actually be a to the s. And now, since we have a logarithm and an exponent of the same base, these are going to cancel out. These are going to cancel out. And as our final answer, we'll be left with 2s plus t. And all we do is we factor out the 2 here. 2 times s plus t is, of course, equal to 2s plus 2t. So we can go ahead and we can select answer A.
All right. We hope these strategies make tackling those difficult problems a little less intimidating.
However, if you're still stressing over these problems, or the math test in general, consider an upgrade to Testive Coaching. Happy prepping!